Alright, we're going to figure out how do we write a quadratic function in standard form. Because I know there's so many times that you're just sitting around wondering, hey, I've got these 3 points, I'm pretty sure that they're on a parabola, but how do I write the equation in standard form? Well, we're going to have to substitute each point xy into y equals ax squared plus bx plus c. We'll rewrite the system of 3 equations and then we'll solve those. Alright, so let's just jump right into it. We're going to write a quadratic function in standard form that passes through the points -1, -3, 0, -4, and 2, 6. Alright, so the very first step is to put each of these points into some equations. So the first point I see is -1, -3. I've got x equals -1, y equals -3. And I'm going to plug those into y equals ax squared plus bx plus c. Well, here I just have x and y, so the y gets replaced with -3, and every x gets replaced with -1. So -1 squared plus b times -1 plus c. So -3 equals -1 squared is 1, so we have 1a, so a minus b plus c. Okay, we keep going. The next point that we had was 0, 4. So if x equals 0 and y equals -4, we have -4 equals a times 0 squared plus b times 0 plus c. So -4 equals, well, a times 0 squared is eliminated, b times 0 goes away, so -4 equals c. And finally, we have x equals 2, y equals 6. So we have 6 equals a times 2 squared plus b times 2 plus c. So 6 equals 4a plus 2b plus c. Alright, I'm going to take these 3 equations and I'm going to write a system of 3 equations with 3 variables. So I'm going to keep all my variables on one side. I've got a minus b plus c equals -3. And then for this next one, I'm going to line it up. C equals -4. And finally, 4a plus 2b plus c equals 6. So if I have a system of 3 variables with 3 equations with 3 variables, I can set this up as a matrix by taking the coefficients of each variable and multiplying it by a matrix of the variables. So the coefficients would be 1, -1, 1, 0, 0, 1, 4, 2, 1. Whenever I multiply that by a, b, c, I should get -3, -4, 6. Well, in my calculator, I'm just going to make this matrix A, this matrix B, and my solution will come from A inverse B. Alright, so now I've gone to my graphing calculator and I've entered all this in. I did the inverse of A times B and I saw that my solution was 2, 1, and -4. So now it's important to remember what these represent. This 2 represents A, 1 is B, and -4 is C. So I can write my equation in standard form as y equals 2x squared plus x minus 4. Now I've taken 3 points and written an equation in standard form of a quadratic. Alright, let's try this one more time. We have the points -2, 30, 1, 6, and 4, 36. So I've got to put them all in equations. My x is -2, y is 30. So y equals a times -2 squared plus b times -2 plus c. So 30 equals 4a minus 2b plus c. Alright, if x equals 1, y equals 6, well then 6 equals a times 1 squared plus b times 1 plus c. So 6 is equal to a plus b plus c. And if x equals 4 and y equals 36, 36 equals a times 4 squared plus b times 4 plus c. So 36 equals 16a plus 4b plus c. So again, in every single one of those, all I did was take x and y and replace x and y in the formula y equals ax squared plus bx plus c. Okay, so now I need to take my three equations that I just came up with and write them as a system. So 4a minus 2b, minus 2b plus c equals 30. A plus b plus c equals 6. And 16a plus 4b plus c equals 36. Change those to a matrix using the coefficients, 4, negative 2, 1, and so on. So I have 4, negative 2, 1, 1, 1, 1, 16, 4, and 1, times the matrix A, B, and C. To write that quickly, sometimes we can just do a big X for this other matrix X. And this will equal the solutions, 30, 6, and 36. Go to our graphing calculator. After making this our matrix A, this matrix B, go to the graphing calculator, enter those. Again, this is a 3 by 3 matrix. This is a 3 by 1. And whenever we do A inverse B, we see that the solution is 3, negative 5, 8. So my function will be y equals 3x squared minus 5x plus 8. And we did it.